This question was asked in the GATE Physics paper 2020. This is a MCQ type question having 2 marks, and the topic of the question is electromagnetism. The question is, a charge Q moving with uniform speed enters a cylindrical region in free space at t equals to 0 and exits the region at t equals to tau according to the figure. Which one of the following options best describes the time dependence of total electric flux phi is a function of t through the entire surface of the cylinder? So there are 4 options given. We have to choose the correct options which describes the graphical plot of phi as a function of t in a proper manner. So let us see how to solve this problem. So it is given that a charge q moving with uniform speed enters the cylindrical region in free space at t equals to 0 and exits the region at t equals to tau. So this is our cylinder. So we are dividing the region into 3 parts. So region 1, region 2 and region 3. So charge is initially at region 1 in the free space. So it is coming towards the cylindrical region and it enters through this surface of the cylinder and it enters the region 2. Then it travels through the cylinder for the time interval t equals to tau. Then again it exits and enters the region 3, which is free space. So we have to find the time dependence of total electric flux as if phi as a function of t through the surface of the cylinder. So that's the surface of the region 2. Now we'll consider the Gaussian surface for this problem same as the cylindrical surface. When the charge q is inside the cylindrical Gaussian surface, that is in the region 2, according to the Gauss law of electric flux, the electric flux is equals to charge enclosed by this cylindrical Gaussian surface divided by epsilon naught, where epsilon naught is the permittivity of free space. Now, in this case, this q enclosed, that is charge enclosed by this cylindrical Gaussian surface, is time dependent. Because this charge is moving, so the charge is inside this cylindrical Gaussian surface for the time interval 0 to tau. So our q enclosed is equals to q for this time interval 0 to tau, otherwise it will be 0 in region 2. So the time dependent electric flux will be q enclosed by epsilon naught, that is q by epsilon naught for the time interval 0 to tau and 0 in otherwise. So the plot for the electric flux phi as a function of t, it will be looking like this. So our electric flux is constant, that is q by epsilon naught for the time interval 0 to tau, and it will be 0 after t equals to tau. So it will be option D, that is the correct option for this question. So we have discussed this problem and we found that option D is the correct answer for this question.